Welcome to Data Binding in a Kotlin World. My name is Lisa Wray, and I'm a Google developer expert on Android. I currently live in Seattle, but it's nice to be back here. And I currently work at a startup called Present, which is a social networking app that brings women together. So in this talk, we're going to talk about the data binding framework on Android, and we're going to do it all in Kotlin. I'll talk about what data binding is, why you might use it, and what it's particularly good for, because it's not good for everything. Along the way, we'll talk about a couple other frameworks that have been released since, or were around before data binding, or that interact with data binding. So you may have noticed I'm talking about two different frameworks today, but they both have the same goal. It's not their only goal, but it's a shared goal, and that is to eliminate boilerplate in your Android apps and to give you fewer bugs. In that, specifically, fewer visual errors from keeping your data streams in sync, and fewer null pointer exceptions, among other problems. So I firmly believe that the less code you have to read, write, and maintain, the better your app will be. So that's my goal here. So this talk is going to be a bit of an exploration. We don't have time to do a full intro to Kotlin or explain all of the features of data binding. So I'm going to assume that you have seen or written some Kotlin before. So if you've seen Kotlin 101, you should be fine. You don't need to have used data binding before, but if you have, stay for the Kotlin tricks. I think you'll find it's fun. So there's going to be three parts here. The first is going to be a highly opinionated overview of the best parts of data binding, as according to me, the person with the microphone. After that will come some Kotlin tips and tricks. And finally, we'll have some high-level advice about how to use the framework to its best advantage. So if you've been to any of my other UI talks, this is not going to be like that. We're going to do mostly code and very few pictures. So I apologize in advance. It's going to be like the worst talk ever. If you leave, it's okay. So what is data binding? What are we trying to do here? And the goal here is declarative functional code. Data binding is basically code generation, largely from Android's XML layouts. So it's a glue layer, which is replacing all the boilerplate of connecting views and models together on Android. All of the set text, find view by ID, and it's much more than that, as we'll see. The way it works is that it generates Java code, but because of great Java interop in Kotlin, it works with Kotlin today. So all of these examples will be in Kotlin. I often get asked as my next question, well, does data binding work with insert other framework I'm in love with? And the question is yes. In general, just yes. It works great with Dagger. It works with RxJava. Obviously, it works with Kotlin, or this would be a real short talk. It works with architecture components, mostly. It works with Butterknife for Kotlin Android extensions, really, if you want to go that route. Things it doesn't work with are things that are generating all their layouts in code. So Anko is the one I get asked about mostly. It occurred to me Litho would also be a good question here. No, it doesn't work with those. It also doesn't work if you're instantiating all of your Java views in code. And if you are, then just don't tell me. Otherwise, it's not because Anko or Litho are bad frameworks, it's just because data binding is centered around the classic Android XML layout. So first, I'm going to give you an example of what this framework does. And this is how you get set up. It's pretty simple. You go to your module build.gradle file, and you put data binding enabled equal true. But wait, there's more. If you're using Kotlin, you may already be familiar with this. If you were using APT, you now need to be using the Kotlin KAPT plugin. And the thing that got me for like an hour when I tried to get started is you need to run KAPT on the data binding compiler. And here, tools version is the build tools version. Once you do this, it works like a charm. So as an example here, we're going to view a screen that has information about a dog. It's not just that I like dogs. I actually wrote this example as my demo app for a dog sitting company. If you ever really, really want to confuse your interviewers, I recommend this approach. Just pick two crazy frameworks and write your demo app with them together. And then just look innocent when they're like, why did you pick that? So here's a simple Kotlin object representing a dog. It's got a name, it's got its owner's name, and it's got a URL for an image. So in this screen, I've removed all the layout attributes so we can just see what's important. We have a normal Android activity layout where the root is a constraint layout. And the first thing to notice is that we've wrapped the whole layout in a tag called layout. This is the cue to data binding that we're going to process this one as opposed to all other layouts. In addition to XML for our views, we've added a data block showing that this activity will have data of type dog, which is my data class we just saw. And we'll give it a name so we can refer to it by a nice name, dog. The second thing is this data binding expression directly in the XML. It's an @ sign with curly brackets. And the last thing to notice is that there aren't any view IDs, and that's because we don't need them here. So I'll come back to this. What do we see here? This is an activity, and instead of the normal set content view call, we're using the data binding util class. That's going to inflate the view, bind the data binding, and then in this case, it's doing the extra work of setting the content view on the activity. And it gives us back a binding, which is the generated class related to our layout. This is generated in Pascal case from the name of your layout file. That is a fancy way of saying camel case, but capitalized, which I learned last week. That class has a binding.setDog method. So when you do this in Kotlin, you can use the property access syntax, and we set our dog object on the binding. I think we're all together here. We're done. So what don't you see here? You don't see any find view by ID. You don't see any setters, and you don't see any getters from the model. All of the boilerplate legwork of wiring up a view to a model object, in this case, 3 find view by IDs followed by 3 setters, is done for us. So this is literally all the code there is. So that's the beginning part, at least, of the magic of data binding. But what if we do want IDs? Well, first, put them back in your layout. Obviously, there are times when you still need an ID, and data binding is here for you in a performant way that is generated at compile time and uses no reflection. So it's doing a single pass of the view hierarchy rather than traversing it multiple times, which could happen in the worst case with find view by ID. And it's going to generate a public final field for each ID. If your names have underscores, they will end up in camel case. So let's start having some fun with Kotlin. We probably want to keep a reference to our binding, because that's how we'll get references to those IDs. We can declare it as a variable, but Kotlin doesn't have nullable types, and we need to initialize this var to something. So we could explicitly declare it nullable until we set it. But then every time we access it, we'll have to use a safe call, and that sucks. So we can make it a late init var. Now we don't have to initialize it until we set it in some method, hopefully at the beginning of our class's lifecycle. This is what late init is for, and we're setting it in onCreate, so far so good. But it's still mutable, and Kotlin really prizes immutability, so you should use a val if you can. So we can go even further and use lazy. Kotlin's property delegation lets me say I'm delegating the setting and getting of this property to another class. And in this case, that's lazy. What it does is wait until the first time we set it, until the first time it's called, here in onCreate, execute this code once, and save the value. So exactly what we were doing ourselves with var, but now it's also immutable. So best of all worlds. But imagine you have to do this in every one of your activities. I'm still seeing some boilerplate here, the data binding util, set content view, blah, 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 blah. So what if we write our own delegate? So here's a first pass at the delegate. If you haven't made a delegate before, it's just a class. There's actually no specific interface you have to implement. It just needs a getValue method. And in this case, we have a reference to the enclosing class instance of the property, which in this case is going to be an activity. That's this ref. However, the problem here with our delegate is that this is going to be evaluated every time we access the property, and we're going to keep binding it over and over and over, which isn't good, which is why we were using lazy. So this is like a poor man's lazy delegate here. This one's not thread safe. Lazy by default is thread safe. But we're going to be doing it on the UI thread, so maybe it's okay. This value here is only going to be initialized once. Only if it's null are we going to perform the binding. And then once it's set, it's non-null. So we have a val, we've gotten rid of our boilerplate, and we're only doing this once. We can get a little bit nicer. To seal the deal, we can wrap our class initializer in a function, so it looks just like lazy. Just kind of nice. Going back to our previous layout, we can do some other stuff here. For example, you can put as many variables in a data binding layout as you want, if you want. And I'm using the property access syntax, but what's going to be generated in our binding is a Java getter and setter for each of these. If you're sending a bunch of them in Kotlin, you may want to go ahead and just group them using... I had a screen which showed grouping them using apply, but then I deleted it. All right, on to property references. If you like Kotlin, then what you do in data binding is going to look pretty natural. The expression language in data binding is not Kotlin, but some things are very similar. It uses property references even if the original class has Java Beans style getters and setters. So for example, you can say dog.owner.name, and it's short and sweet. This expression language also has null safety in property reference expressions, but with one big difference in the Kotlin, it's not like a Kotlin safe call. So you might think that the expression dog.name with null safety would evaluate to something like this, where the text fuse text only gets set if the dog and its name are not null. But that's actually not the case. It's more like this, where the text always gets set, but if there's a null, then it'll get set to the default value for that type. So if you have an age, which is an int or a long, it's going to get set to 0. So unless you like your dog being born in 1970, this is something to watch out for. You can also make new XML attributes, one of my favorite parts of data binding. For example, you can have an image attribute, which takes in an image URL. I'm sure all of us on our first day of Android development thought this is really how source works in an image view. I'm happy to say it's come back home. So there are 3 ways: automatic setters, renamed setters, and custom bindings. The last one is the only one you'll really do yourself. So for example, I'm sure we've all encountered an Android class where something is only possible through Java and not through XML. Well, if there is a public setter with the same name as the attribute, then you can consider this a sort of synthetic attribute. Data binding will look for a setter with the same name as the attribute using Java naming conventions. So this also means that if you use a custom view with data binding, even your own custom view, you don't have to define your attributes in code anymore, unless you want to. You can just give them the same name as your setter. Renamed setters. This one's pretty simple, and it's already done for you. For example, the Android tint attribute is actually associated with set image tint list. That's nice enough. All right, custom binding adapters. Why isn't my slide advancing? All right, custom binding adapters. There's my slide. These are my favorite, it's true. So I was excited for these when they were first announced in 2015, as I was for Kotlin extension functions. And that may seem crazy, but this is why. It's the ability to fill in any attribute you've ever wanted or thought was missing in the Android framework yourself, and you can just make them up and add them. So here I'm going to use this image attribute as my example. There are 2 basic ways that you can do this in Kotlin. First, you can put them at the top level in any file, and they'll be available anywhere in that package. It's really hard to overstate how powerful these adapters can be at blowing away stupid boilerplate that over the years you've just taken for granted. So for here, for example, you can just use your image loading library of choice. Stick it in there. You can also, it's worth mentioning, you can also take multiple attributes. So here I'm calling center crop on all of my images. But if I wanted to have a separate scale type, I could take that one as an additional parameter and specify it in my binding adapter where I'm saying image. It would take image and scale type. Another place you can put them, if you'd rather put them inside a companion object, that's fine too. You still need to remember the binding adapter annotation, And you need to annotate the method with JVM static. Especially as a Kotlin beginner, that one was not obvious to me. Another nice thing, it's a little throwaway, but it's nice, resources and expressions. If you have ever written these things like dimen A plus B, dimen image padding plus small padding, no more. You can just add them in your layout directly, so that's nice. You can also perform basic logical operators with them. You can do string formatting and plural formatting right in your XML. There is a whole expression language, and this is my personal opinion, but again, I'm up here, so you get mine. Inside the data binding expression, in your XML, you can do a ton of crazy things using this expression language. And there's quite a lot of it. But code in XML freaks many people out, and for good reason, I would say. So the mere idea, the possibility of putting code in your XML is what has made a lot of people boycott data binding entirely in the first place. So it's really simple. Not only do you not have to write code in your XML if you don't want to, I think you shouldn't do it. The docs spend a lot of time talking about this expression language, and I think that is misleading at best. I think you should bind a view model. I think you should use the expression language for a proof of concept or a quick prototyping tool. But in general, don't use it. It's fine to bind like the simplest of views and models together if you really just need to stick them together with no processing. But the minute you start writing logic, use a view model. I'm not here to sell you an MVVM architecture, and I honestly don't care what you do. But data binding and view models are BFFs. As a bonus, instead of writing a weird made-up binding language, I'm so sorry you came in at this moment. In your view model, you can write beautiful, beautiful Kotlin instead. So let's see what that looks like. You can use any plain old data class for data binding, but modifying it won't update the UI. So the real power of data binding is giving your data objects the ability to notify when data changes. And there are 3 different ways to do this: observable objects, observable fields, and observable collections. I don't tend to use fields and collections. A lot of people do. I'll show you what I prefer in a second. The idea is that when one of these observable data objects is bound to the UI and a property changes, the UI is going to get updated automatically. And that means you don't ever get it wrong. So in this example, we're going to consider a screen where the user enters information about a dog and eventually can hit the submit button to save that dog. So here are some observable fields. I don't personally use these very often, but they're great for one-offs or when you're just starting to convert a data class, or if you just have a couple fields. So you use them by substituting observable fields for the original types in your model, and you set them by using the getter and setter methods. And because this is the way you access them, unfortunately, this is what it looks like even in Kotlin, so it's still a bit verbose. The good thing is that nothing changes in your XML. Observable view models, in my opinion, are the real prize here. So what I usually do is I have an observable view model that extends base observable. Observable is the interface, and base observable is an abstract implementation which does some work for you of registering properties and providing methods to notify changes. So it looks like this. You're going to annotate your bound fields with @bindable, and that lets data binding generate BR properties for them. Those are kind of like R values, but for data binding. And you can use those to notify the property registry. I think BR stands for binding registry, but don't quote me on that. So to notify in the setter in Kotlin, we're going to have to implement a custom setter for our variable. First, you have to handle setting the value, and then you call the method on base observable notify property changed with your generated BR entry. In Java, this isn't terrible, but I'll admit in Kotlin, the custom setter syntax actually makes this kind of gross. But we can do better. So first, as you might imagine, we can try rewriting this using a delegate. So observable delegate is another property delegate built into Kotlin. And it gives us a chance to do something when the property changes, like notify that the property changed. And this isn't bad. There's also a shortcut way of writing annotations, which seems a lot nicer to me. So this is already a lot better than when we first started. But I don't think it goes nearly far enough, as we are aiming to destroy boilerplate and not just improve it. So here we are with a completely custom delegate. So now we can do dog name by bindable delegate and pass in the initial value and the BR entry. And I'm using bindable delegate here because I didn't want to create a namespace conflict. So it doesn't get a lot more compact than that. Here's the implementation for this, and it does look a little impenetrable compared to the other delegate, but it's really not so bad here. So this delegate is operating on a class extending base observable, that's R, and it's going to handle any type of property, that's T. It requires an initial value of the property type, and it also requires the binding entry, like br.yourProperty. For value, it's just returning its internal value. And when it sets the value, it calls notify property changed on the class that's extending base observable. And finally, for maximum code appeal, why not also wrap this one in a function? So I think we can all agree this got a lot better really fast. So now we've gotten our bound observable properties looking as good as they can. I wanted to demonstrate one more thing that observable models can do that's really nice. Suppose I want a submit button that's enabled or disabled based on whether the user's filled out all the fields. So I can do that with dependent properties. Here, submit enabled depends on dog name, and every time dog name changes, data binding will update the enabled state of the submit button automatically, so it will always be in sync. So you might have been thinking, why is that dog name always an empty string there? How is that helpful? How does it ever change? Well, this is my favorite and the easiest, in my opinion, part of data binding, two-way data binding. So let's take this edit text in an input form. And in this case, we're not pre-populating the value of the dog's name. It's just an empty string, and we'd like the model to be updated when the user changes it. So if you look closely here, you may notice the @equals in the data binding expression, and that's the indicator that it should use two-way binding. So with this one character change, the public setter of dog name is now called whenever the user changes its value. So if you ever use a text watcher to create this kind of listening to user input, you know how amazing and low effort this is in comparison. You can also write your own custom binding adapters for two-way binding for your own custom attributes. I just don't have time to cover it right now. Next, we'll look at event listeners. So these are probably the most controversial part of data binding, other than the expressions. They do rub some people the wrong way. The first one is way to do it is listener objects. You can kind of see how I feel about it. These can be helpful if you already have a code structure where you declare explicit listener objects, and you just want to move them straight over and use this as the glue to attach them. You could put these, for example, in an object called callback, so that contains all your click listeners, and bind that. OnClick here is just a shortcut for onClick listener. You can use method references. So now we're getting somewhere. These look just like Java 8 method references, but they're in your XML. The tricky part here is getting your method's signature to match the signature of the callback. For example, here you need to know that after text changed is passing you an editable. And there are custom properties that are already made for you. In this case, you can see that they've decomposed the text watcher interface. So that is really helpful. You can also use Lambda expressions in your XML, yep. And you can pass custom parameters here. Like user would be your own custom data that you declared as a variable. Unlike method references, if you don't like the parameters, you can change them. But you have to take all or none of the default Android parameters. You can't just pick and choose. Other than just syntax preference, there is a difference when method references and lambdas are evaluated. A lambda isn't evaluated until the event occurs. A method reference is evaluated eagerly at binding time. And just so you know, the standard Android onClick that's been there forever from the XML actually does use reflection. So both of these methods are going to be more performant than that. Some people love these event listeners. Some people can't stand to see them in XML. So they're a really good way to cause arguments with your team. They are a great way to eliminate writing boilerplate, but they can also complicate your architecture, and some people feel they pollute your view model. So more on this in a moment. So if you're not convinced and you still think, I love writing boilerplate code, I have a few examples for you where I feel data binding is particularly helpful. In most cases, the most expensive thing you can do is draw views. And in drawing views, the most expensive thing you can do is to redraw the whole screen. So in this sense, data binding is as efficient as the best possible handwritten update code. It uses bitwise flags to mark the fields dirty, and it only changes fields that are actually changed. So only those areas of the screen are invalidated. If you have closely interrelated UI components, some examples of these would be sign-up forms or content input forms, where you need to provide some kind of on-the-fly validation, such as fields being empty or not. If your components depend on each other's state, or if you have ever considered using a state machine to model your view, then consider using data binding. It will really simplify your life. Here's an example of related components. As a bonus, they are also in a recycler view in the app that I made at my last startup. This is a song lyrics viewing app, and you can leave comments at the bottom of the page saying just how much you love hearing Justin Bieber saying Despacito. So here I am, I'm filling out this form, and the submit button is either enabled or disabled, depending on whether I've filled out all the fields. So data binding makes this really, really easy. You define the state of your button as a function of the inputs, and then data binding just gets it updated for you at the right time. But there's an additional trick here. This button is a common component, and I didn't want to duplicate the layout or have another item. We used it everywhere, so I wanted to just reuse the layout we had. So these are two separate recycler view items in this form together, and they're sharing a common view model. So when changes happen in one, they're being reflected in the other, but only while the item is bound. So we're getting safe updates within the recycler view lifecycle. You could do this with payloads, but it would be way more of a pain in the butt. So this is a really fun way to use data binding. Another fun use is encapsulation of view components. It is a great alternative to custom views, which do not require custom drawing. So for example, in this layout, which I admit is a bit contrived, I would like to put 2 dogs at the same time. And instead of making a custom dog view and then putting 2 of them in my layout, I've simply included the dog layout twice, and then I'm able to bind 2 different dogs, one to each layout, in a way treating them as custom views. Along those lines, you could also have many, many different layouts, each of which is still simply associated with a dog object, and it's just as easy to bind any of them to your dog model object. Some other fun tricks are animations. Ooh, I forgot the border there. So I actually got these ideas from a blog post by George Mount on Medium. If you make a binding adapter which animates as it handles changes, then you can do things like animating the state of a switch. This one is using a custom attribute, animated visibility, because if you just hooked it to Android visibility, you would get every visibility change animated. So he gave a complicated example which handles checking the current alpha and making sure you don't jump when you start the animation. It occurred to me this would be fun to do with a physics-based animation, which would handle the partial change. Another fun way to do this, which is even more general, is view transitions. You can add an on-rebind callback to your binding. So this callback is going to be called in a very general way. It's on your whole binding, and it's when any property has changed. And it also doesn't even tell you which one has changed or to what. So what use is this callback? I really don't know, except for this one use case where you can tell the transition manager to begin a delayed transition. And that says, wait for a change, and when it happens, pick the best way to animate it, and it will just do it for you. That's what the transition manager does. So this one, to me, is really cool and very low effort. Another one is activity or fragment transitions. If you've ever done them from a recycler view, you know that each one of these items in a recycler view needs to have a unique ID. Otherwise, your transition is just not going to happen. So traditionally, you would have to do that programmatically, probably in your recycler view item, and then also in the destination fragment. With data binding, you can just have this happen directly in your XML or in your view model if you want. And finally, it plays well with others. So this is the number one question. What does RxJava have to do with data binding? Can I use them together? The answer is, sure, you can use them together, and they actually have fairly little to do with each other. They are both frameworks encouraging functional programming. You can use them together, but the Rx observable has nothing to do with the data binding observable, and they are not interchangeable. Some things to notice: why would you still want data binding if you're using RxJava? Well, RxJava does not handle, for example, view partial updates for you, whereas data binding is specifically designed to do that. It also doesn't handle, for example, interrelated properties. Another good point is data binding does not deal with threading. It has absolutely nothing to do with asynchronous computations, which is what RxJava is great at. Another thing I've seen is there's an on-property change listener, which you can get from a binding. I've seen people hooking this to an RxJava observable, like wrapping it and getting events that way. This can lead to unexpected results. I think it's best to consider that data binding is not an event bus for UI events. If you need observable RxJava observables, it's best to attach them directly. So the two of them work together fine, and in practice, they are fairly different. Other view binding frameworks, I get this one a lot. Well, we use Butterknife everywhere. How could I possibly tear it out of my project and start trying to use data binding? Well, you don't need to. Data binding would probably be overkill just for view references. And if you already use another view binding framework, that's probably pretty small. They're not going to conflict with each other, and it's okay to try and bring one in gradually. So the example I like to give here is that data binding is kind of like bringing in a Swiss Army knife to work on your project. And if you happen to leave one butter knife in your project in the meantime, it's going to be okay. There's a note I want to say on Kotlin Android extensions. These are really cool, and I understand why people are using them. It's about the least boilerplate I could imagine for getting references to your views by ID. However, the find view by ID value is being cached in an activity or in a fragment, but currently they are not cached in other places, such as in custom views or recycler view view holders. So if you are using them right now, they've fixed this as of 1.1.4, but you need to enable an experimental feature. So if you haven't actively handled that, and you're using Kotlin Android extensions in your view holders, then go take a look at that right now. The data binding is a good option in this case instead. Dagger is another question that's very common. Yes, there is complete cooperation between Dagger and data binding. You can inject things using Dagger into your data binding adapters if you want. You have to implement the data binding component interface. There was a talk last year at droidCon by Jacob Tabak called Advanced Data Binding in Practice, where he stepped through this, although not in Kotlin. The biggest problem with these frameworks is if you have an error in one, because they are both annotation processors, everything that happens after that will fail terribly and in a really scary way. Unfortunately, this is happening with any annotation processor and not unique to these two. So once you know to expect it, it's less terrifying. Another question is architecture components. Can you use data binding with live data? Well, yes, you can. There's actually an example right now, the GitHub browser sample that Google has written, which is using live data, Dagger 2, actually, and data binding together. However, it's not a very close integration. And the problem with my preferred method is you can't extend both base observable and live data. So there are some alternatives. You can use the observable fields that I was talking about that I don't use very often. You could implement observable yourself, which is a little extra boilerplate. I think we're going to see as it goes forward what people's preferred way of dealing with this is. So what's the catch? Well, right now the biggest problem is that with Kotlin and data binding, your errors are dumped into the Gradle console. Yeah, the Gradle build console, and that's not where I thought to look for them. Errors can also sometimes be a little obscure. They're much better than they used to be, but luckily there's a lot of help on Stack Overflow these days. So this was in no way an exhaustive overview of everything data binding can do. It does much more, and I encourage you to play with it and see what it can do for you. As for its future, it's continuing to be actively developed by Google. If I could have a wish list, it would include every Java example in the docs also being shown in idiomatic Kotlin. And I would love to see delegates like a few of the ones I've demonstrated here for the common causes of boilerplate with data binding, like notifying observables or inflating and binding layouts. I don't think I have time for questions, but if you have questions about data binding, I'll take them later. If you found problems in my Kotlin, keep them to yourself. Thank you very much.